Okay, we're going to try something different today. I found some really interesting things for you. Today we're going to be talking about acceleration. This lovely picture we're going to come back to later. Ready?
To break it down, I'm making a connection. I know that speed is the rate of change in position, and velocity is both speed and direction. I'm free up sufficient to deal with your rejection. Why don't you hear me? Why don't you hear me? Why don't you wanna stay? Speed is distance divided by time. Is distance divided by speed. Is distance divided by time. And distance and distance and distance is speed times time. Distance is speed times time. Distance is speed times time. And speed's right. To break it down, I'm making a connection. Velocity is both speed and direction. A change in velocity is acceleration, which can occur by changing speed or direction. Now don't you need me? Now don't you leave me? Now don't you walk away? Speed is distance divided.
So, what were those definitions that we just looked at? Well, position is the location of an object at a given time. Distance is how far an object has gone. Speed is how fast an object is going. And velocity is the speed and direction. Remember, in this class, we're only going to have positive and negative. Acceleration, then, that's the new one. This is the change in velocity over time. Let's look at another example.
When we are in a stationary car that moves rapidly to gain speed, we get pushed back against our seat. And when brakes are applied, we get pushed ahead. Or when we take a sharp right turn, we're pushed towards the left. These are all situations where we are accelerating. We have all experienced this, whether in a car or a bus or while riding a motorbike. Simply put, when velocity changes, we have acceleration. I still haven't defined what acceleration is. I just told you that when velocity changes, there will be acceleration. Okay, let me give you two examples. In the first one, a car is traveling in a straight line at a constant speed of 80 kilometers an hour. And in the second one, a plane is traveling in a straight line at a constant speed of 1000 kilometers an hour. In which case do you think acceleration is involved? None. In both cases, the velocity is not changing at all. Hence, there will be no acceleration in either of the cases. Most people relate acceleration to high speed, and that's clearly not true. Acceleration will only exist when there is change in velocity.
So, let's look at our three examples from before. Remember that acceleration is a change in velocity over a period of time. So if I am speeding up, I'm accelerating. If I'm slowing down, I'm accelerating. And if I'm just changing all kinds of direction, I'm still accelerating. Let's look at another one. The top one up here, where's my pretty pointer? This top one, this was like your buggy car. He was going fast. This is like your bubble tube. Steady, slow, little bits at a time. This one here, this is still constant speed like the buggy car. But this one's accelerating. Notice how the dots get further apart? And this one down here at the very bottom, if that'll go away, is really accelerating because the dots get way further apart. So what happens if the dots get closer together? Is that still acceleration? Let's find out. On your formula sheet, Add this to your formula sheet. First, here's your equation for acceleration. A is equal to delta V over T. Now, delta V just means change in. Say, change in. Velocity, remember, is a mixed unit. It's a distance unit over a time unit. And there can be lots of different ones. The main one we're going to use is meters per second. So remember, velocity is a mixed unit. Time is in seconds, minutes, hours. It's a single unit all by itself. And therefore, because velocity is already a mixed unit, acceleration is a double mixed unit. It is a meter per second, or a mile per hour per second. It's a change in velocity over time. Remind me in class to show you the triangle of power for acceleration. Let's look at a couple of examples. Example 1. A car accelerates from a stop to 60 meters per second in 6 seconds. What is the car's acceleration? Remember, you need to use our equation formula, right? EWA. Acceleration is a change in velocity over time. The velocity changed, it went from 0 to 60, so it changed by 60. 60 meters per second in 6 seconds. 60 divided by 6 is 10 meters per second per second. Let's look at another one. A car traveling at 60 miles per hour slams on the brakes to avoid hitting a deer. The car comes to a safe stop after applying the brakes. What is the car's acceleration? Well, remember, acceleration is a change in velocity over time. Don't know why that's moved. But this one, notice what happened. It went down by 60 miles per hour, right? It's still changing, went down, so we use negative for down. In 6 seconds, that's a negative 10. Look at those units though. Miles per hour per second, because it's that double mixed unit. All right, you're going to be working problems today in class. Thanks for watching.